Good morning, students. Class 9 Science, and today we will continue the previous chapter, that is light. In the previous class, we studied about reflection of light, lateral inversion, curved mirrors, ray formation for concave mirror. So, let us continue our class with the convex mirror. Convex mirror. Convex mirror are the mirror in which reflecting surface is curved outward, and it is used for rear view mirrors mostly in vehicles and also used in blind spot in shops. It always forms virtual erect a small sized image of the object. So, we have already studied the image formation of concave mirror. So, similarly, we will be studying the image formation by the convex mirror using 4 important rules. Let us see these rules one by one. Rule number 1. A ray of light which is parallel to the principal axis of a convex mirror appears to be coming from its principal focus after reflection from the mirror. So this means that before reflection, ray of light will be parallel to the principal axis, but once the reflection takes place, this ray of light appears to come from the principal focus. So here the ray of light gets changes from principal axis to principal focus. Rule number 2. A ray of light going towards the center of curvature is reflected back along the same path. So this is very easy one. So this means that whenever a ray of light is going towards the center of curvature, after the reflection, it will be coming back to the same direction. Rule number 3. A ray of light going towards the principal focus of a convex mirror becomes parallel to the principal axis after reflection. This means that whenever a ray of light which is going towards the principal focus after the reflection, it will become parallel to the principal axis. Rule number 4. A ray of light which is incident at the pole of a convex mirror is reflected back, making the same angle with the principal axis. This means that whenever a ray of light which is coming and striking, it will be reflecting back and it will be making the same angle, that equal angle with the principal axis. Till now we have studied so many rays, but any two rays can be chosen to draw the position of the image in a convex mirror, and you must know that all rays behind the convex mirror should be drawn in the dotted lines. Have you ever wondered why do stars twinkle, or what makes the star twinkle and shine? So, if you haven't wondered till now, then no problem, because today you will come to know the reason behind the twinkling of the star. So, let us start with the actual reason behind the twinkling of the star, that is refraction of light. Refraction is the change in the direction of the wave or ray passing from one medium to another. This means that whenever a ray is coming from one medium to another, suppose if the ray is coming from air and then suddenly it comes to the water, then it will change its direction. Now you will be thinking why it happens. So let me tell you, this refraction happens because of two things. One is density between the two substances and the change in the velocity of light in different medium. Now tell me, have you all understood the reason behind the twinkling of the star? Yes, the reason behind it is the refraction of light. So what makes it? Have you all understood? Let me explain you. Okay, so what happens? The star is at a very far distance. So what happens? The light from the star comes to the earth. But do you think the light do not find any obstacles on its way? Yes, it finds so many obstacles because there are so many gases, so many layers, and each step these layers and gases have its own density. So what happens? This light will be traveling from different medium, different density. Then what happens? At every density, at every step, these lights will be changing its direction, because we know refraction is what? It's the change in the direction of the light ray. So this is why it happens, the twinkling of the star. Why? Because it keeps on changing the density and the velocity of its light. We have learned till now that whenever a ray of light passes from one medium to another medium, then it changes its direction. So now let us know what happens when this ray of light passes from lower density media to higher density media. Lower density medium is called rarer medium and higher density medium is called denser medium. So whenever a ray of light passes from lower density medium to a higher denser medium, then it will bend towards the normal. And when the ray of light passes from denser medium to the rarer medium, then it bends away from the normal. And if incident ray strikes directly on normal, then there will be no deviation takes place. There are two important laws of refraction. So the first law is the incident ray, the reflected ray and the normal at point of incidence all lie in the same plane. And the second law is called Snell's law, that is the ratio of the sine of the angle of incidence to the sine of the angle of refraction is a constant for a given pair of media. Thus, this constant is known as the refractive index, which is equal to sin I by sin R, that is velocity of light in air by the velocity of light in glass. Next we will see total internal reflection. Total internal reflection. It is defined as the phenomenon which occurs when the light rays travel from a more optically denser medium to a less optically denser medium. Actually, this total internal reflection is the combination of reflection and refraction. So, let's have a recap about the reflection and refraction. Reflection is defined as the bouncing back of the light, and refraction is the change in the direction of the ray of light when it travels from one medium to the another medium. To understand total internal reflection, we are creating one situation. That is, we are taking two different medium. One is water and the other one is air. So, a ray of light is allowed to pass through the water to air. So, why we are taking first water and not in the air? Because we know that total internal reflection takes place from higher density to lower density. So, this water is having higher density than the air. Now, a ray of light is allowed to pass from water to air. Can you think what will happen now? Okay, I will tell you what happens next. Since the light ray is passing from higher denser medium to a lower denser medium, the refracted light ray bends away from the normal. So, did you find what happened here? Yes, refraction happened. Next, you know what will happen? Okay, let me tell you. At a specific angle of incidence, the incident ray is refracted in such a way that it passes along the surface of the water. This particular angle of incidence is called critical angle. And you know, when the angle of incidence is greater than the critical angle, then the incident ray is reflected back to the medium. So, have you come to know what had happened here? Yes, over here in the second part of the experiment or second part of the situation, reflection has taken place. Let me tell you, in the first step, like when it was passing from higher denser medium to the lower denser medium, then the refraction has taken place, right? And in the second time, when the angle of incidence is greater than the angle of critical, then the reflection has taken place. Now this entire phenomenon, like refraction has also taken place and the reflection has also taken place. So this is called total internal reflection. Some example of total internal reflection is twinkling of the star, formation of the diamond, that shining nature of the diamond is due to the total internal reflection, and the formation of the mirage in desert, etc. With this, we have come to an end of the chapter, and I have a small homework for you, that is to find the formulas for the total internal reflection and read the chapter thoroughly. Thank you.